Good morning, it's Peter from Lithium Power here. Today we're doing a demonstration on the advantages of connecting your solar panels together in series rather than parallel. Most often in small applications, low voltage applications, they're connected in parallel, whereas domestic solar panels are connected in series, and they run up to 600 volts DC by running the solar panels in what's called a string. We've got a 60 amp lithium iron phosphate lithium power battery here. We've got it on a load so that it's always charging. There's 5 amp load there with a few lights going. We have a EP Solar 2210A tracer unit, MPPT solar controller with the remote display that is obvious just in front of you. In a moment I will put up a graphic of how to connect them in series rather than parallel. At the moment we've got our solar panels connected in parallel, as is commonly the case, and they're putting in 12.3 amps. They're also running at around 15 volts out of the solar panels. And I'll just disconnect them quickly and reconnect them in series, and we'll see what happens. It's quite a simple matter, as you'll see, to actually disconnect and reconnect them. So they're now connected together, and our solar panels are now running at 32 volts, 30 volts, double the voltage, and they're putting in 7.3 amps. So you can see that it's quite a considerable increase in the amount of current that's flowing. The amount of current that's flowing in the battery you'll be able to see on the solar controller directly in front of you on the display, remote display, and you can see that it's actually bumped up by about an amp, which is about a 20% increase. And the other interesting thing about having them connected in this way, when you're at the fringe time of the day, your solar panels are running at a much lower voltage, and so this enables you to gain the benefit of getting solar much earlier in the morning, generating power through until much later in the evening, because the voltage is higher, so the MPPT controller can still keep pumping in voltage into your battery. Now the graphic that I've got, hopefully it won't reflect in the sun too much, and you can pause the video if you want to be able to see it clearly and work out exactly how to connect up your own panels in this manner. And we can see that on the left hand side here we've got the two panels, an MPPT controller and our battery, and they're simply wired positive to positive, negative to negative. With a tracer 210 like we've got now, the maximum that we can put on there is 260 watts of panels. The panels that I've got here are in fact 300 watts. There's two 150s, so we're a little bit over what we should be. We should only have a maximum of 130s. If we go to the series connection, it goes negative out of the MPPT through one panel, then that's connected to the next, and then back around to the MPPT. So, and that's going into our battery. Now with the same controller, our maximum is 24 volts, and our maximum power is 520 watts. The other advantage of this is that your wiring can be smaller on this because the voltage is higher. The current, because the voltage is double effectively, the current is halved for the same amount of power generation. Remember, these are generating a certain number of watts. Going by Ohm's law, V equals RI, and watts is worked out the same way. And so if we've got a voltage of 24 volts, the current in that 24 volt line is actually half what it would be in this one here at 12 volts, or nominally 12 volts. It's actually about 15 to 18 volts. So this one is 30 to 36 volts. The current, of course, going to the battery is not changed in either situation, either wiring circumstance. So hopefully that makes it clear to you, and please look out for my videos on YouTube. Thanks.